Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. Now, I have something different on my bench today. This is an SAE T3U Stereo Tuner. This is a T3U standalone tuner. It's a big unit. It's the size of a full-sized receiver or amplifier, but it's just a tuner. So I kind of expect there's going to be some empty space in here. But this is a rare bird. I don't see any SAE equipment around my neighborhood. This came from a client. He wanted it fixed up to use. He said it had a problem with the dial. It wouldn't stay on frequency or something. He said he would set it to the station and then it would move off. I don't know what he means by that. If we got tuner drift, that's one thing, but he says it's something to do with the dial cord, and he said the pointer was crooked, but it seems to be working now. Now I kind of suspect something's wrong with the dial string or the dial pointer with this, because when I was carrying it around, there's something rattling inside. So I think something loose got jammed, and maybe it jammed the pointer and things weren't working properly. Even though it seems to be now, it seems to have full free range in all of the frequencies, and yeah, it's an AM/FM tuner. And the other problem he mentioned is some of these switches are stuck. Like this muting button is stuck in, it won't unlatch. And I think these are probably standard or fair switches. The AM mono auto blend switch was kind of stuck, and this one's stuck definitely. So I don't know if these took a hit or if something is wrong with them mechanically, but we can service the switches. He told me that these switches are unobtainium and they can't be replaced. I don't know about that. I haven't seen what kind of switch they are. Maybe they are some kind of weird switch. This is actually made in Japan. SAE typically built their equipment in the States out of American components, American build quality. But this is a Japanese, spawned in a Japanese factory, and it's really nice look to it. I love this two huge meters on the front and then your dial scale all along the bottom. It's got a really cool design to it. It's all black. It's aluminum face on this. It's got a brushed anodized finished. It's got some quality look and feel to it. And like I said, it is big. On the back we have AM bar antenna that swings out. Inputs for 375 ohm, which is pretty typical output, and that's it. Nothing else. No fuses, no level control, nothing else. Scientific Audio Electronics Incorporated, Los Angeles, California, and model T3U. So before we plug it in and test it, I have to think it's going to be working. But before we test it, let's get the covers off and search for any broken pieces floating around, just to make sure we're safe that way. Now it is a little beat up. These side pieces, these side caps for the front, you can see the plastic's broken off. I don't know if that's just the plastic kind of disintegrates and crumbles, or if that was an impact. Probably more like an impact that hit that and broke those off. I don't know what I can do for this. Might be able to epoxy a washer on there maybe, I don't know. But yeah, I suppose the best thing to do is 3D print a new one, but you won't get the quality and finish like this one is. So I'm going to try repairing these if I can. I don't know. See what I can do with that. Okay, time for the big reveal. Nice steel lid. And wow, look at this thing. I have a power supply section over here. And this is all tuner. Switching. These switches aren't, these are very common switches, so there should be no problem. I like these big meters too. These are cool. 1978. I guess that's the date code on this 78. Let's see. There's a 7 here, so this might be 77, 78 maybe. 77. So this might be 78 vintage. Check out this tuning capacitor. I've never seen one like this before. Super fine plates on the AM for the AM section, and then they have 1, 2, 3, 4, 5 capacitors for the FM section. They're doing some serious tuning here with this. I have to make sure I close this so I don't damage those plates. It's so fragile. If you bend any of those plates, you got an immediate short circuit. But yeah, I've never seen them that fine. It's quite a quality capacitor there for sure. Alright, and this is all mounted as a separate tuning block. It's separated off the main board, and this little circuit here is separate from this board. So for capacitors, we've got a mix of Rubicons, these light blue ones, and Matsushita caps, which is these purple ones here. So I fully expect the Matsushita ones to be dead. And we might even have a shorted Rubicon or two if run across those before. Power supply has Rubicons in it. Everything looks intact and normal. So yeah, this is nice. I don't see any problem with the dial string. Let me look around and see if I can find something in here. So we got evidence of a previous repair. This black insulating board here broke for this RCA output, and somebody grabbed a piece of scrap metal and used it as a clamp to clamp this down. I'll see what I have for this. I don't know if I have one that'll drop in and replace it, but I might have something. So I'll see. There's no fixing this right now because this piece is missing, but it's secure. It's probably working and secure. It just doesn't look good here from the inside anyway. On the outside I didn't notice. And then I did find something rattling around inside. It's a push-on nut. So usually these are pushed onto plastic posts, and the post breaks and nut falls off. So I don't know where this came from. It's got glue on it. So we have something here that's missing this nut. So I'll keep looking around. But this might have been jammed in with the dial string. Dial string looks like it's working good. It's not binding anywhere. I thought it would have a lamp on this. Maybe we could add an LED on there to light up that needle. That would be cool. Be a nice mod to make. Maybe we'll try that. But the problem is this thing has a wide range of travel, and you'd have to get your wires proper so that they don't bind or get caught on something when they're going back and forth. So that might be a trick to that. Okay, somebody lost the fasteners for this front dial glass, and they just jammed in a random M4 self-tapping screw, and they jammed it in. It's not even seated all the way down, but it looks like how, and it's jammed in there. So I'll have to find some proper hardware for this, something that looks nice on the outside. Yeah, that's not the right screw for this. Good thing they didn't crack this by putting this big thing through it. It would have expanded and tried to crack the plastic. I'm just going to leave this in place for now just to protect the dial pointer. Put it on loose. But if I look on the other side, here, you can see, I think that's where that push-on nut came from. So they had probably a plastic peg, and yeah, they had a push-on nut, and somebody wanted to remove it, and they busted the post. It does have lighting on both sides. It has an incandescent lamp on this side, and it side lights the dial scale. So the dial scale should glow. I think it has white lettering. Yes, it does. So the lettering should glow, and that's good if both lamps are working. Alright, time for a first power up. So here we go. Dial scale is lit. Went up to 9 watts. Everything looks normal. Let's plug in the amplifier. Amplifier's on, and I hear silence. Let's see, it's because I'm wrong input. This is AM, right?
Your challenge is to mash up a horse with a horn.
It's working good on AM.
Amounts of bark off our trees.
Not getting very strong signals, but then it's pretty quiet too. Okay, usually there's nothing on the top end. Okay, let's go to FM. We got a dirty tuning capacitor. This switch gets stuck in. I just give it a thwack and it comes out. So we might have to either lubricate that or replace it. So tuning capacitor has got problems. You can hear that noise. And then we completely lose it because the oscillator is stalled. Right. I don't think we have shorted plates. I think we have just dirty connections on the tuning shaft. So a drop of deoxit. Let me do that and then we'll come back. I'll show you if it worked. Okay, this might be difficult for you to see, but between each gang of tuning capacitor, there's these brass plates, and their job is to make a ground connection to this brass rod, the shaft. And there is 1, 2, 3, 4, 5, 6 of those plates, and they all make a grounding connection. And it's kind of a spring metal, and as the shaft rotates, there's a sliding contact there. So I'm just going to put a little tiny drop of deoxit 100 at each location. Looks like this lubricant's all turned dark, and so I'm just going to give it just a little touch. And this one I can't reach at all. Maybe I can. I don't know if I can get in there. Yeah, okay. We dump some in. So now what you got to do is work it back and forth a few times. And the deoxit will get into the area where the slide is happening and kind of clean it and lubricate it. This tuner's got a nice action to it. It's actually really well built. Okay, I'll do this a few more times off, and then we'll bring it back and we'll listen to it. Okay, let's try this one more time.
Sur le côté, tout est de.
And you notice that crunchy noise is gone,
On now at Marks
and it tunes in nice. There's no dead spots.
And I get green egg and ham.
Seems like it's pretty sensitive. Oh, that's a lie.
Well, nope. Dental on Mayfield Road. Or what if? Like what if?
On sale during the Sephora savings
Stereo lamp is very dim.
Early Friday, April 10th via
I don't know what.
April 14th. Offers end April 20th. Shop in store or online at Sephora.ca.
You rock. Now.
Probably needs an alignment. Let me see here. Yeah, the tuning meter is a little bit off. When you have zero signal coming in and you're just getting interstation hiss, that tuning meter should be right on center, but it's not. It's off a bit. So that tells me it's just a little bit out of.
On the first, second,
Of every jewelry collection.
Yeah.
It seems to favor this side, the needle. So that tells me the discriminator is off balance a bit.
And that country song.
maybe not.
Thank you.
It's a good working tuner. Just needs to be cleaned up. It's pretty dirty. It needs a lot of cleaning and probably needs alignment. And it probably needs new caps too. I think I'm going to go through the effort of putting new caps in this. It probably deserves it. It's a nice tuner and it's a keeper. Lamps are both working. If you can see the lamp, the dial scale, there's no lamps. Oh, there are lamps behind the meters and they're working too. So you really don't have to do anything to this other than clean it, align it, and maybe a few fixes, and we're good. One of the complaints the owner had is it wouldn't hold station, it would drift. So what I'm going to do is put it on a station here and listen to it for about an hour and see if it does drift. I can't see a tuner like this drifting off station. It sounds really nice. So I'll come back in an hour, I'll let you know how it worked out. Okay, this thing's been running for about an hour, hour and a half, and it's rock solid. It's not moving off station at all. The front panel, you can see how dirty it is now. You can start to see the windows, the haze and the dirt. This will clean up really nice. This is aluminum, anodized aluminum, and it's got some plastic inserts for the switches and LEDs. But yeah, this is a nice condition. It's not damaged. It'll clean up really nice. You can start to see the dirt inside. You can see the filth inside this dial scale is at an angle, so it's going to collect dust. You can see that, and that's going to clean up nice. It's going to sparkle like a gem. What I'm going to do is start recapping. This is very easy to work on. Got full access on both sides. And I'll do a recap, and then we'll get onto an alignment. I'm probably going to pull these switches out and service them. This one still sticks. These three are okay, but this one, yeah, there's something wrong with this one here, and I'll just take the whole assembly out, clean all the contacts, make sure you got good contact resistance, and reassemble. And this will be like brand new, these switches. Lighting's good. Lighting's working. Everything's all original. I'm going to see what I have in my parts stash to replace this. I should have something. And if I don't, I maybe look online if I can buy something that fits in here. I wanted to make it look as stock as possible, so it shouldn't be too difficult though. I just want to get away from, I don't want to be cutting sheet metal to make something fit. That's what I don't want. So I'll see what I have. If I don't have something, I'll buy something. It's got a real bass heavy note to it. I don't know if that's going to be maybe because the highs are a little attenuated. Maybe the caps in this thing need refreshing. Maybe that's part of the problem. I don't know. Looking back here, I don't see anything. This is the output here. There's a relay, a Fujitsu relay. That's a nice touch. And then it's got the outputs here. I think these two caps are probably coupling. And then I think we have a little bit of amplification here. Another couple caps. These are 1 microfarads. These could be dead too, these Rubicons. And this is our trap filter. It's a low pass filter to make sure that none of the 19 kilohertz gets through. And yeah, so I'll get started on caps. That's the first step. Okay, just going through doing recap, and I come across this cap here, a C851. It's on the switchboard, and as far as I can tell, this cap is across this black and white wire here. I don't know if you can see that black and white. The black goes to ground, and the white goes to the stereo lamp, and it's doing some kind of filtering. So this completely, legs rotted off. There's no legs left. They're completely corroded. And it's not from the conductive glue. The conductive glue wasn't even touching. Whatever reason, this cap leaked, and the legs are completely gone. I don't know what that does. I think it just filters the power going for that stereo lamp. And I did notice the stereo lamp was quite dim when I first tested it. So maybe this is probably the cause. But we'll put a new one in. So I did manage to find another connector, and this is a drop-in replacement. So I'll replace this get that done, and then that's it for any repairs or retrofits I need to do. Caps are all in. I just need to clean boards, clean the front. It's still dirty. I serviced the switches. These are all working now, and they're all cleaned, and that's ready to go. So all I have to do now is cleaning and alignment. So let me get this this RCA connector in, and then we'll move on to that. So what I'm going to do is I'm going to go through and try and attempt alignment. Now I don't have any service manual, no specs for anything, but this is pretty carbon copy for a lot of receivers, tuners of the era. They use a standard 3 chipset. These, in this case, they use the LA, where is it? LA1231. This is an FMIF chip, and you can see that too because it progresses from the front end here. Right here is where the signal comes in. It goes into this tuned resonator circuit. That's the FM front end, and then it goes into an RF amplifier. This is a 3SK45, I believe, transistor, and this is pretty typical for front ends to have a stage of RF amplification before they go into the mixer oscillator. And this one here would be the mixer oscillator, and that would be run from this capacitor, I believe. So we have input, tuned resonant circuit, RF amp, another tuned resonant circuit into the RF our oscillator mixer, and then these are running this capacitor here is probably running this oscillator, and then they have two more, probably an IF amp, and then it comes out here. We got ceramic filter, 10.7 megahertz, and then another, looks like another IF amplifier, and another ceramic resonator, and then it runs into this 1231 IF chip, and then from there it processes the IF. And this other chip here, the LA1240, that's our AM. So this is here all AM section. So this red can here, this would be our RF oscillator, and then we have IF, and I'm not sure what that one is, discriminator, but this can be all tuned up. And this here is IF, and then these are probably our discriminator coils for the FM. So one would be our zero balance, and the other one would be the distortion. And then it goes to this chip, and this is the multiplex. This is the LA, which one is this? LA3350, and you can see it's got some trimmer pots here that are set for the 19 kilohertz oscillator and stuff like that. So I could probably fumble my way through this and figure it out. There's really nothing to align in this front end. They have these coils, 1, 2, 3, 4, and these coils are adjusted by spreading them apart or squishing them together. Now I probably don't have to touch those, they're all tuned, but we have the capacitors on the top here. And so yeah, I'll go through and do a crude alignment. See, I don't think it needs much of a touch-up. Basically, more what I'm concerned about is dial accuracy and discriminator distortion. Try and get that down as low as possible before I send it out the door. So I'll do that. I'm not going to film any of it, and then I'll bring it back and we'll do a listening test maybe. Okay, so I just did a test video. Now the test video is kind of deceiving. I picked the weakest station in my local, and that's a 900 watt station, and it's 16 miles away from me. So I barely get that signal, but I have a rooftop antenna amplified with a 30 dB gain amplifier, and it comes in fairly strong for the tuner, but it also brings a lot of noise with it. So the test video is very hissy and noisy, and it's not typical of a typical commercial station in my area. The commercial stations that come in and have a good signal are pretty much noise free, and but so like what I'm getting at is that test video is probably the worst case scenario this tuner would ever see. Now when I listen to it with my bench speakers, it sounds horrible in that it has over too much bass. It sounds boomy, and it sounds like the highs are muted and attenuated. But then when I took the video and listened to it on my on my editing computer. It sounded fine. It was, well, like I said, it's a weak station, and you know, it's what you're working with, right? Now, could be a couple reasons for that. I thought at first maybe this thing was defective in a way, the way it was booming my bench speakers here, and it really isn't. It just, my bench speakers are just not the greatest. Now, you need to understand that FM broadcasts use a system of pre-emphasis and de-emphasis. Okay, what's that? Okay, well, it's pre-emphasis is done at the radio station, is where they boost the highs, and it's boost according to a specific amount at a specific frequency. They call that a pre-emphasis of, for example, for North America is 75 microseconds. But on the receiver end of things, they used a de-emphasis, which is the opposite effect. It kind of attenuates the high frequencies at that same rate that it's boosted at the radio station. It's kind of a crude noise reduction. It's used quite a bit. You could almost think of it as like Dolby that they use on tape decks, and the RIAA equalization used on turntables is kind of the same concept. They boost some frequencies after they attenuate frequencies, and then they record the program material, and then when you play it back, you boost certain frequencies or attenuate depending on what you're trying to do there. And they use that system to cut noise. And the station hiss, you're going to get hiss from your FM broadcasts. Now, if that de-emphasis isn't correct, you're not going to get the correct amount of attenuation at the receiver, and you might get too much attenuation or not enough. For example, FM broadcasts in North America use a 75 microsecond pre-emphasis, and in Europe they use a 50 microsecond pre-emphasis at the radio stations, and then the receivers built for those markets do the opposite. Okay, and they brought this pre-emphasis de-emphasis thing back in the 60s, I believe. I was trying to look it up, but I couldn't find a date, but I think it's in the mid 60s sometimes. So all the receivers built after that time should have the correct circuits in it to de-emphasize the broadcasts of the day, right? So I think this is correct after listening to it on my stereo. I might do another test video with a strong commercial station. Problem with commercial stations is they do a lot of signal processing. There's limiters and there's compression, and you really can't get away from that. Now, another problem I'm facing right now is I'm porting the tuner directly to the camera, and the camera itself has a automatic gain adjustment. So in between songs, when there's no music, it boosts the gain, and up comes the hiss signal. You can hear it very prominently. But then when the music starts, it drops down again. The gain drops down and adjusts itself to hold the music program at the same level for recording onto the video. And that's kind of messing up the sound too. So it's kind of misleading what I'm doing here by porting this directly to the camera. The camera's kind of messing it up and before it encodes it. The blend, when I kick in the blend, you can hear the hiss dramatically drops, because what the blend does is it attaches a capacitor between the two channels, and all that high frequency information is shunted together, and you lose stereo separation, but then you also lose noise. It's kind of a trade-off, right? It doesn't attenuate any high frequencies. All it does is it blends the two channels together at high frequencies and causes the noise to be reduced. Now, what I think I'm going to do is I'm going to connect this up to my equipment. I'm going to do a frequency response plot on this tuner to see how the frequency response is. We should have a flat response up to about 15 kilohertz, then it should drop off pretty steep. The reason they cut it off at 15 kilohertz is because we have a 19 kilohertz pilot tone, and you don't want any of that pilot tone getting through to your tweeters. It would smoke them in an instant. So that's what they do here with the filtering. Let me show you. So this here is our multiplex circuit. This chip here handles the multiplex, and what it does is it takes the audio information with the 19 kilohertz pilot tone, and it has an internal 19 kilohertz oscillator that locks to it. and what it does is it separates your left and right channel, and it produces two channels, you know, left and right, and then it runs it through these two filters. These are low pass filters, and these are tuned. They're fairly steep filters, there should be anyway. I don't know any details about this because I don't have a service manual, but these should attenuate all signals above 15 kilohertz to block all this 19 kilohertz nonsense that's going on here, so that none of it gets through. And then they have these two capacitors, and they look like they are between left channel and ground and right channel and ground, these two, and they are 56 nanofarad capacitors. That might be our de-emphasis right here, and if it's a capacitor to ground, it's going to shunt high frequencies depending on the capacitance. So I can do a frequency response plot of this and see how flat it is, and if I'm not happy with it, I can change these two values to something smaller and let more of those high frequencies through. Another thing I can do is I can feed a modulated 19 kilohertz signal in, and I can tune these two. They should be traps. It's actually a filter and a trap to trap the 19 kilohertz because they don't want any of that getting through, and I can fine tune these. There's really no reason to adjust these unless you have a problem, but I can check it by feeding a signal through and see how much, scope the output and see how much signal is getting through, and then I can do that too. So I think I might do that. First I'll do the frequency response plot, and I'll see how that turned out. I don't have any specs on this. This is what bugs me, because I like to have manufacturer specs, and they would state in there what the frequency response would be and how flat it should be, but I don't have that. Anyways, let me get busy on that. I'll get a plot done, and then I'll maybe tune these two up. I'll feed a 19 kilohertz modulation in, and I'll see if these are doing their job. Okay, what we're looking at here, that's a 17 kilohertz signal. Let me get the trigger going here. Okay, so this is a 17 kilohertz signal in the left channel, doing the left channel only, and I'm going to increase the frequency of the modulation up and go to 19 kilohertz, then pass through 19 kilohertz. So then I'm go up slowly, and you see as I go up, this is 17.5, the amplitude drops, 18 kilohertz, see how it drops, and then if I keep going, now I gotta remember I have the receiver set up on mono, so it's not gonna kick on the stereo and try and demultiplex the signal. It's just gonna go straight through. So 18.1, 2, 3, 4, 5, 6, 7, 8, 18.8, 18.9, 19 kilohertz. So we have all our signals gone, which is what we want. If I go up in resolution, I don't think there's any signal there. Let me keep going higher. 19.1, 2, 3, 4, 5, 6, 7, 8, 9, 20 kilohertz. So you see the signal's coming back now. So we know that 19 kilohertz trap is working. It's removing all of the unwanted signal from the program. You go back to 19 kilohertz. Let me try adjusting one of these. I'm not going to adjust them far. I'm just going to off tweak them a bit. So here's the left channel. If I go, see, I gave it about a quarter turn on the trap, and the signal came back. Now I can null this out, go the other way. So I can fine tune this to get rid of that 19 kilohertz, and right about here is where it was correctly adjusted. Let me try the other coil. This one doesn't have any effect, so I think it is more not the trap. I think that is more a let's go down to 17 kilohertz. Okay, let's get this right. I just want to adjust this other slug and see what it does. Okay, so it kind of maximizes the signal up to that point, and it looks like it's already maxed out. So I'm going to leave these adjustments alone. I can check the other channel, but Leave these adjustments alone because they are correct. So these ones I was adjusting, this is the left channel. This gray one here, that's the trap, 19 kilohertz trap, and this one here is the filter, I believe. So they are adjusted correctly. I'm going to leave those alone. So here's a look at the frequency response for this tuner. So I use 1000 hertz as my base point, which is 0, and then go up from there, down from there, depending on which frequency I want. So I checked on these frequencies going down. So at 500 hertz, it boosted it 0.6 dB, 0.7 dB, 0.5 dB. So that's between 100 and 1000 hertz here. This is why I'm getting that booming sensation, or the booming sound. I think there's a little bit of a boost here. And then when I hit 50 hertz, it goes the opposite way. It drops by 0.4 dB. And when I hit 20 hertz, I'm down 4.8 dB overall. And my negative 3 dB point is at 26 hertz. Okay? Going the other way, going up in frequency from 0, 2 kilohertz drops 1.8 dB, 4 kilohertz is 5.5, 6 kilohertz is 8.5, and you can see how it drops off here. When I get up around 12, 14 kilohertz, we're down about 14, 15 dB, and it really goes down. And then when we hit down here, we're down in the noise actually. So our negative 3 dB point is 2.7 kilohertz. So yeah, I think this shouldn't be quite as steep. Our de-emphasis should start around 2.7 kilohertz, and I think it's 6 dB an octave. I'm not sure how that works. I think this is going to be fairly correct. This is the signature of how this thing sounds, right? So you're getting attenuation at certain frequencies. I think what I'm going to do, just to try out, I'm going to remove these two 56 nanofarad capacitors and install 47 nanofarad capacitors. That's going to drop the capacitance a bit, and I'm just going to see, do another plot in the frequency response, see how that changes. I expect to see a little bit of difference. We'll see how much it makes a difference. It might be an improvement. We'll see. I'm going to try that. Alright, so I replaced these two caps. These are 56 nanofarad. Took them out and put 47s in their place. They're out. Here's what's changed. So on the low end, pretty much nothing's changed. We're talking about 1/10 of a dB difference. And my 3 dB minus 3 dB point at changed from 26 hertz to 27 hertz. No big deal. On the other end of the scale, above 1000 hertz, we changed about 1 dB. Well, here at 2000 hertz it didn't change much, but beyond 2000 hertz and up we gained about a decibel of frequency response all the way down, and our 3 dB point changed from 2.7 kilohertz to 2.9 kilohertz. It bumped it up a little bit, so it gave a little bit of a better high-end, mid-range and high-end response to the tuner. Is this correct? Who cares? Does it matter? If your ears enjoy it, do it, right? So I think I'm just going to leave this alone and leave this mod in place, because this tuner does sound a little dull to me in the mid-range and high-end. I think I need a little help, so I think this is a good mod for this tuner. I'm going to leave this as is, and I'm going to go with it. Okay, for these end caps, I almost forgot about them, having to deal with something. These are pretty dirty. I'm going to ultrasonically clean these, and then I'm going to, you can see the plastic, it's kind of smashed here. I don't know if that's brittle plastic or if that was an impact, but it's on both sides, right? Now you also got to notice that this profile here, this post is higher than this. This one's flush, this one's protruding. So whatever I have to do, what I'm going to plan on doing is I'm going to take a Dremel and carve this down probably about 1.5 millimeters or 2 millimeters, just thick enough so I can get a piece of scrap plastic, cut a piece of scrap plastic, put it over here and epoxy it in, and then once it sets up I can drill a hole, and that'll provide an anchor for these two screws, and that should be the end of that. Alright, so here's the caps that went into this. These are all been replaced. There was actually 2 failed caps in this lot. I think Rubicon It was one of these, I think it was this one. It was a 47 microfarad, and it was starting to go short circuit because it measured way up around 70 microfarads. Yeah, I think it was that one. Doesn't matter. And then all these Mashashita caps surprisingly are okay, but these are all small value. These are 0.47. These were all replaced with films. They'll never go bad now. I removed one bodge off the main board, and these are the two capacitors I swapped out, and the RCA jack on the back got repaired. So that's all the parts that went into this. Alright, I'm going to end this one here. Really pleased at how this one turned out. It cleaned up really nice. It was quite, it had a, you couldn't really see it on camera, but it had a nicotine glaze film, and everything and I cleaned it, it always came back with a dirty rag. So now it's clean, it looks good, sounds good. I like this large meters and this full dial scale on the bottom here. I think that's pretty sharp. But this one's going to go back to the owner, and thanks for watching. I got, if you're interested, I have lots of tuners in the queue that are waiting for the bench. Let me know down below if you like to watch tuner repair videos. I know it's not for everybody, but I plan on doing them sooner or later, so let me know. Alright, thanks for watching, take care, and we'll see you on the next one.